Hi guys, welcome to my shop. I'm Robin. This is part 2 of the custom calipers videos, and in this we'll carry on with the carbide pins, putting radii on them, putting a spherical radius on the ID measuring jaws with the lapping setup, making the actual pieces that are going to get brazed into the Mitsui Toyo calipers that have been modified, and should be some interesting stuff. Let's start now. Okay, I got my 50 thousandths pin, diamond file, and some 15 micron diamond film. So I have a 5 thousandths radius called out on my drawing on this edge. It's basically just to make it so that it doesn't catch and scratch the part that you're measuring or cut you. It's a pretty fine diamond. The secret with diamond is to let the diamond do the work. Extra pressure in this case is not a help, especially on the diamond film. And I have you can tell which side's which from the matte side is the diamond film side. I've already gone over and looked at in the microscope at this to see what my technique is producing, whether I'm getting a decent radius edge on there or not. And that checks out okay, so looks like I'm working blind here, but I've already done one of these and got my technique down to do that. So I'm very, very gently pressing on this, letting the diamond do the work. Yeah, that's nice and smooth. You don't want it to be catchy at all. And you obviously don't want to do what I just did with my finger on one before you deburred it. Okay, that's it. I'll do the rest. I have a real fine diamond disc in my flexible shaft handpiece here, and I'm just spinning these with my fingers and chamfering the ends. These are the 16th diameter ones. You can see we're just putting a break edge on there so it's nice and smooth. This is the setup that I'm using to put the 0.4 spherical radius on the end of the 16th diameter carbide pins. I'm using a hollow 3/32 ID piece in my hand piece of my flexible shaft, and I have it set at the correct angle to get roughly a 0.4 radius. So it's canted at 7 degrees in the little bracket that I've made to hold it there. And that 7 degrees will end up generating that 0.4 radius spherical in there. You can always take two circular elements like that, get them at the correct angle, and create a spherical surface as one sweeps past the other. So that's what I'm doing here. So the flexible shaft is up here. Drive you up there to the actual motors hanging up there on my stand. That's my camera mount for the camera, which this camera will be in shortly. Got my gas pedal down here on the floor for the flexible shaft, and I have a steel tube that I'm using to actually get this end shape on here initially. So I'll put these in and out and use about 15 micron on that tube to actually get the spherical surface. Once I've got that, I'll switch to aluminum tube and 3 micron and get the actual finish on it. Put a little 15 micron slurry in there, turn our part on, hit the flexible shaft, see all the black generated there? That's carbide particles. There we go. I know it could do it. There's the spherical end on there at hopefully 0.4 roughly. So that came off real quick. So I'll do each one with the 15 micron here, and then we'll come back and put the aluminum in to finish it. So to check to make sure that I have that radius, I actually put this held it up to the light. I'm not showing you in the camera, but held this up to the light and made sure that I have contact at the center and not on the edges. So I'm definitely, this is a 0.984 bearing ID, and I'm just using it as a radius gauge to make sure that my radius is smaller than that, and it's good, so I can carry on and do the rest of these with the rough. I'm going to change to the aluminum lap, so I'm just spinning my, get my index in there. Loosen that up. Steel lap out. Aluminum lap in. Tighten this up. Gentle snug on there. Now the only thing I have to do is get my offset here, because I'm cutting with a 9/32 diameter bore in that tube, so I need a 1/64 of an inch of offset here between the so that's 21, 16, 15. Okay, so what I'm doing there is I'm getting the, since I know this is a 16th diameter pin, so it's 32nd from the center to outside, and then the wall of this lap is 1/64, 15 thousandths. So I'm setting this edge inset 15 thousandths to get the edge of the 9/32 bore right on the center line of the part. Now I'm going to go get the 3 micron. Okay, I've got my 3 micron. And we'll go ahead and just turn this on slow, and you see all that black? That's carbide coming off of there. Okay, see what that looks like. It's looking pretty good. I still think I have some tool marks from the 15. Not tool marks, but yeah. Just needs a little bit more time. There, get the light on it.
This is the same edge rounding treatment as on the 50 thousandths pins, just using the plated diamond file. And then you'll see me using a resin bond lap here, which is just a little smoother cutting action on the edges there. This particular pin will have more of a tendency to catch on the edge and scratch if it's not properly radiused. And then using the same 15 micron diamond film. Now we're using 1 micron film to actually polish the spherical end to get a decent finish on the end of that. The 3 micron lap actually left a more than adequate finish. This is just a little icing on the cake here. Again, gentle pressure on the film. It looks like I'm pressing hard on that. I'm not. It's just my finger dimpling around it. Here's the pin. Not optical quality, but more than sufficient for a gauge surface.
Now that we're done with the hard parts, we're going to move on to the easy parts. These are the jaw attachments that will get silver soldered on. This is for the face groove caliper. This is for the ID groove caliper. This is the 50 thousandths reamed hole that will grip the pins that we just made. 080 screw, Torx head screw will be clamping those. Be obviously a right and left on each of these. Here's our tongue that goes into the groove that we ground in the calipers. Same on this one. This one we've got 16th reamed hole, obviously, and 2 080s that are clamping the pin, and the same tongue. And when I was grinding the tongue, I realized that they didn't get as centered as I'd like, so I basically moved them around to get an even 40 thousandths wall on either side. So these scratched out dimensions here where I modified that to match. And this is just to keep everything together, give some more silver solder bearing area, keep things from flopping around while we're silver soldering, and hopefully that'll work well. This is the cross section that's going to engage in the groove that we put in the caliper. So the caliper groove here is going to match up with this tongue that I'm showing here, highly enlarged. So this piece, the cross section of this right here, is larger than this just by a little bit. So I'm just going to mill just the tongue on there, leaving some excess material on the top and the bottom, such that we're going to silver solder it in. Then I will finish, grind, drill, tap, whatever the pieces after they've been silver soldered in. So rather than finish all the details of this piece, all the features, these holes need to be very parallel and in line so that the pins are oriented properly for measuring. So silver soldering could leave all kinds of distortions, so it's just safer to do that after it's soldered on. So I'm going to mill the cross section of this on this piece, and I'm going to do somewhat similar on the other piece where we have the much longer piece. But there's the tongue. You can see there at the top. That's the tongue that goes into the caliper. So that will be lining up like this in the caliper out here. So this I will do the same thing. I'm going to leave excess material on this. This is actually at thickness, but this thickness isn't critical here. That extra bump out there is just for getting some more thread engagement on that 080 thread. That's the only reason that's thickened there, is to get some better length of engagement for the threads. So that can vary. It's one of the beauties of being the designer. You can adjust things on the fly as you go along. So that's what I'm going to do. I'm going to do the edge treatments on these, get them prepped so they fit the caliper nicely, and then we'll section these. Once we've got that, we'll cut these into segments that are the appropriate length, still oversized, that we're going to silver solder onto the bar.
Cleaning up the one edge, flipping it over, making the other edge parallel, using the side of the end mill here to square the end to the side, two sides we just did, flipping it over, squaring the other side. Now we're all squared up.
Okay, now we have to mill this down to about 0.147, leaving a band of about 3/8 of an inch here for the thicker section. Just one little tip here. I keep a little. This is just a chunk of A2 that I hardened, got hardened in one of the batches of hardening. It's real smooth on the one side. It's got a coarser finish on the other side, so I know which side to hit on. And for tapping down things that are finished, this is real handy to just be able to tap on something that's finished and not leave marks, so you can get your parallels tight. So just a handy piece. So we're putting our piece on a parallel to get up above the vice lip there, half-inch parallel. And then we're going to stick another parallel in here to enable us to clamp on the actual upper surface so that it doesn't deform. So I'm just showing you here on the end so you can see what's going on, but I'll put it centered in the vise.
Machining the edge of the piece for the 40 thousandths distance to match up with the groove that's in the calipers. Here we have the other piece that's from Precision Ground flat stock. The edges are never square on that stuff, so I'm just taking a skim cut on this to get the edge actually square to the main surface of the piece. Then I'm going to flip it over and mill the other side to actual drawing dimension. Now when I go to grab this sitting on these two parallels, the piece will tap down nicely and actually grip. A hardened A2 block there to tap it down with. Feeling the parallels, they're snug, and now we're going to take it down to drawing thickness on the part. Now we're going to stick it up so we can mill our lip, just like the other one. The step for the lip to have the tongue to fit into the calipers.
One technique when you're doing multiples like this, where we intentionally did a cross section on one larger piece where we're going to dice it up into other pieces, is you saw that we squared this up all sides. Now when I go to saw off a piece of this, alright, there'd be a temptation to just saw off the pieces and lose the squared edge. So a technique that I always use is saw a piece off, come back, re-square sitting on this surface, this datum which we know is square, saw, re-square, or re-mill, saw, re-mill, all your way down, so you never lose your squareness and never have to try to re-square a piece, especially when they're going to be long and skinny like this. These are only going to be about 3/8 long, so these are going to be strips like this. So I'll saw this piece off with a little excess to mill, then I will mill this edge of the big piece sitting on a parallel here to maintain my squareness and march my way down through the pieces. So I have my stop set here on the roll-in saw so that I can just get that length that I'm after. And then for times like this where the piece is a little bit thinner than my stop, I just use a backup block here to hold it in place. So I just clamp that with the clamp. Run right through. Exciting rumble ride there with the camera sitting on the tabletop. Now here's what I'm talking about, where I'm going to go mill this now parallel to the bottom and not lose my squareness. So here we are sitting on our parallel, and we're just going to skim the top. Now just deburr this, go over to the saw off a piece, come back and mill it again.
But no one knows my story. Until now.
Doing some deburring here on the pieces, getting them ready to be silver soldered in. These edges will all be ground away. Here's 20 thousandths parallels of the set that I made way back out of spring steel, blue temper spring steel. Wavy parallels, which I find most useful for springing parallels tight against the jaws. So here you'll see I sandwich them in there with a spacer block so that these parallels stay nice and tight against the jaws. Cleaning the jaw off and a piece of spring steel here with the edge ground straight to use as a stop, little Black Max 380 Loctite super glue. And I hold this up tight against the part, squaring it against the part, down tight against the vise, and then I can use that as a nice low profile stop. Spot drilling the holes for the 080 screws that'll pinch the 16th pin. Now I'm drilling my tap drill hole for my 080 down through. Put my tapping head in. It's just a floating torque set tapping head with a 080 spiral point tap in there. Tapping these with the under power. Just hand chamfering the backside of the tapped holes with a small carbide 6-flute chamfer. Another setup with the wavy parallels as to load the parallels, keep them in place. And we're going to go through and do our edge drilling. The 20 thousandths parallels come in handy here because we're getting awful close to the edge. Spot drilling for the 16th, 2 16th holes there. Drilling the pre-ream hole for both those holes. Using the one hole as a flexure hole, so I might as well just make it the same size. Using the cool tool too there also on the drilled holes. 16th reamer going down through. Thinning down a woodruff cutter to 15 thousandths wide to slit these parts.
Okay, full disclosure. Here's what that woodruff cutter that I was going to slit those 15 thousandth slits with looked like after my first slot. So that's why we backed up to using the cutoff disc, the 20,000 cutoff disc.
So I need to make some flanges to hold a 20 thousandths wide, 6-inch diameter cutoff wheel, grinding wheel. So I'm slicing a chunk of aluminum in half here on the roll-in saw, and take those over to the lathe. Warning, some barbaric tool making practices in progress here. I'm going to snap the depth rod off of the frame here with a pair of vice grips. They're just tack welded on, and you can see there, I'll show you the tip there where it's, you can see where it was welded in. Taking the outside 6-jaw chuck, the Harding 4-degree taper nose, cleaning that up, getting ready to go on the spindle. Very nice chuck mounting method, works really, really good. Just snugging it up, that's all it takes. Here's a chuck stop system that I've built for both chucks. There's 3 pieces like this that bolt on in each place. Lets you slide radially to where you want. Has 2 steps to match the steps of the jaws, and adjustable legs. Those legs were made out of socketed cap screws, and they were case hardened with caseite like material. A torch, mounting them on there, positioning radially, setting the amount of grip length that I want, snugging up the screw to lock that position. Put the indicator on the first one that I set, zeroing it. Now moving over and adjusting the second. Now I'll use my little 4mm box wrench there to adjust the position right in place. And with those hardened with the case hardening, they actually stay nice and sharp and crisp. The hexes on those works really nice. So you get that in place, and then lock in with the socket head screw that's pinching the threads there. Go to the third one. I think I might have over traveled the indicator, so I'm going to crank it in some. Go back and check the first one again, make sure my 0 didn't move, and then come back and adjust the third one to match. Just tweaking that with the 4mm wrench again. This is nice because you can set any size you want, and you can get it as precise as you want on your face position. Lock that up. Ready to go. Put my saw cut disc in. Going to put a drill in to put my hole in there so I can bore my 1.25" holes for the wheel adapter. Turn the OD to cleaning off the face. Like I said, we're just making flanges here for 2 of them for holding the grinding wheel. Taking a finish cut here on the face. Bore. Chamfer. Chamfer. And you can see the belly in there that I got from the fact that we're gripping on one edge of the part and intentionally tighten the chuck firmly to get that dish. So that makes the flange grab harder on the outside edge, which is what you want. Just double checking my 0 on my stop pins on the chuck. Make sure they didn't do anything crazy. And you saw my indicator mount there on the lathe, which is real handy. Put the piece back in. I'm going to face it off parallel. Notice I have no compound on the lathe. That's intentional. That tool post is locked in place and aligned and never moves. I do have a compound I can put on when I need it, but that happens about once a year. Chamfering the ID. Okay, now we're going to go use a tool to put a bevel on there. This is just eyeball. Trying to get the lip off of there. Need to move the tool over a little bit to get. Yes, I'm really close to the chuck jaws. Like I said, it's just purely for aesthetics and being able to see better. Filing the edges off there. There's a safe edge on that file. Taking off a wheel that I'm not using to use the wheel adapter. Got a whole bunch of these where I used to work. Customer sent in a bunch of wheels and didn't want the wheel adapters, and they were pretty nasty. So those are glass bead finish you see on there. So I rebored them and used them. 20 thousandths wide wheel. There's play on there because of the threads. So I'm going to use my scale and just try to rough center it so that we don't chew up a bunch of wheel from run out. Just get it in the ballpark. Once we've got that on, put our washer on. Left hand nut, tighten it up with spanner wrench.